This is the summary for Lesson 14, 4 representations. And in the summary, the authors look at 3 of those representations and how you can see the constant of proportionality in each of those representations. So here's a graph, here's a table, and here's an equation. And the constant of proportionality is circled in each case. 7/4, 7/4, and 7/4. And so for the graph, since this is a proportional relationship and the graph goes through the origin, then you can look at the x-coordinate and the y-coordinate, and the y-coordinate divided by the x-coordinate, 7 divided by 4, is the constant of proportionality. And what that means is for every 4 units, there are 7 units of the y value, whatever y is. So whatever x is, you take 4 units of x. That means you're going to use 7 units of y. And remember that the y value is dependent on what you choose for the x value. Now, if you want to get this to what happens with 1 unit, what's the unit rate? So instead of using 4 units of x, you use 1/4 as much, or 1 unit of x. And for that 1 unit of x, you use 1/4 as much as 7, which is 7/4. So 1/4 of 7 is 7/4. This is the scale factor. To go from 4 to 1, it's 1/4 times 4. To go from 7 to 7/4, it's 1/4 times 7. So one way to get to that constant proportionality is look and see what happens for 1 unit. And in this case, for every unit of x, you have 7/4 units of y. That's almost twice as much. 8/4 would be twice as much. 8 divided by 4 is 2. 7/4 means that you get more of the y units for every 1 unit of x, and almost twice as much, 7/4 as much. For the equation, it shows the same thing. Y is equal to 7/4 of whatever x is. So 7 divided by 4 is the same as 7/4 divided by 1. So 7 divided by 4 is 7/4 of 1. And we'll look at this in a moment, but 7 divided by 4 is equal to 1 3/4. And 1 3/4 is that 7/4. And so y is 7/4 the units of x. And so y divided by x, that's how you get to the constant of proportionality, is equal to 7 divided by 4, or 7/4. So if you ask the question, how many of these units of x can you get out of y, whatever y is, you can get 7/4 as much. So 7/4 of these units of x. So that's the meaning of the division. So y divided by x is equal to 7/4. That means that y is 7/4 of x. You can get 7/4 of x out of y. If you have whatever amount you have for y, how many of these units of x can you get from that? You can get 7/4 as much. So y is equal to 7/4 x. And finally, in the table, at the value of 1 unit of x, y is 7/4. 2 times 7/4 is 14/4, which simplifies to 7/2, but 14/4. So 7/4 divided by 1 is 7/4. 14/4 divided by 2 is 7/4, because you're multiplying by 7/4. So if you divide by 2, you're going to get that 7/4 back. 21/4 divided by 3 is 7/4. So how many of these units of 3 can you get out of 21/4? You can get 7/4 out of that. A little bit hard to say and think about, but the point is that y divided by x is equal to 7/4. And you can look at it as, if you're multiplying by 7/4, then you divide by the other factor, you're going to get that 7/4 back. So 4 times 7/4 is 28/4, which is equal to 7. Well, 28/4 divided by 4 is 7/4, or 7 divided by 4 is also 7/4. 7/4 right here. And finally, x times 7/4 equals 7/4 of x. So y equals 7/4 x. So every place you look, every representation you look at, you can see the concept of proportionality is 7/4. And the authors are just trying to get you comfortable with looking for that value of 7/4 because that's what you use in the equation. And finally, if you look at a single unit x, the value of y is 7/4 the amount of that single unit of x. So if x is equal to 1, y is 7/4 of that 1. It's larger. It's 7/4 as much, almost twice as much. 1 3/4 as much, which is also the same as 7/4 as much. Now, on the other hand, if it's not a proportional relationship, then the line of the graph is not going to be straight. It's not going to go through the origin. It might not go through the origin. It can't be both of these. It can't be both straight and go through the origin. So it might not be straight. It might not go through the origin. It might be straight and not go through the origin. If the equation cannot be expressed in the form of y equals kx, so you can't write an equation like this, and a table does not have a constant of proportionality. So when you take all the values of y and divide them by their corresponding values of x, you do not get a constant answer. You get something other than a constant answer, which would be the constant of proportionality if you got a constant answer. If all these things are true, it says, you take the first number, you can multiply any number in the first column and get the associated number in the second column, then the relationship between the quantities is not proportional, meaning there's not a constant of proportionality. If this does not happen, you get different values. The associated number in the second column does not have a constant of proportionality that you can multiply by any number in the first column to get the associated number in the second column. Then it is not a proportional relationship if you cannot do that.